when adding polynomials, we may see them just in a list like this, but more often you will see them with a group of parentheses. When we are adding a group in parentheses, it's just as if the parentheses are not there. So I'm still going to be combining like terms across the whole statement. Because I have an x to the fourth over here and an x to the fourth over here, I might want to put a box around both of those just to keep in mind that they are to be combined, and I would connect them just to be sure of myself with that, and then I will underline these two terms including their signs and note to myself that those need to be combined. If I have 9 of something plus another 9 of that same thing, that means I have 18 of those things. If I have -3 of something and I'm combining that with 7 of that same thing, I really have -3 plus 7 or +4 of those things. Now we have the same idea going on here, except sometimes we don't have all of the same pieces in each side. So this is where using the boxes can really help you. I have an x to the third term here and an x to the third here, so I'll put a box around those, and those will be combined. I only have one term that's to an x to the second power, so I don't really need to put any mark around that yet, but I will use a circle for now. I have a -3x, which I will underline, and I have a +2x, which I will underline. The +7 doesn't have any terms that need to be combined with it, so I can just leave it by itself. The reason I put a circle around this x squared term is I wanted to make it look different than this +7 so I don't combine it. So if I have 5 of something plus 4 of something, that means that I have 9 of that thing. If I have -2x squared, there's nothing to be combined with, but I still need to have my x squared second because my exponents need to be in descending or decreasing order. Now I'll look at my x terms. I have -3 of something plus 2 of something, so that would be -1 of those things. And again, I don't need to write the 1. And now I finally have a +7 to add. Likewise here, I'm going to look at the same thing. I have x to the 6th, and I have an an n to the 6 over here. This should be an n, not an x. If it were an x, I would leave it by itself because it can't be combined with any of these others, but for these purposes, it should have been an n, so I know that these two can be combined. I have a -5n to the 5th, which I will underline, and I have another -5n to the 5th, which I'll underline, so I'll connect those two together. And I also have a +9n and a +2n. Notice how with these two terms, if I'm going to connect them, I have to cross over this line here. So I used a symbol that looks different to remind me that I need to connect them, but I really don't want to draw that line here because it could be confusing. If I have 7 of something plus 9 of that same thing, that gives me 16 of those things. -5n to the 5th plus another -5n to the 5th would be -10n to the 5th. I don't have any fourth, third, or second powers of n, and because I'm not doing division, I don't need to write them with a 0 coefficient. I'm just going to move on to the next one that I have, which would be a +9n plus a +2n, which would be a +11n. You will know that you have combined like terms properly when you have 3 separate, or in this case, multiple separate terms that have the same variable, but all the exponents are different.